Previously, Ahmed kicked off his final year project by first screening and identifying his target microorganism. After multiple of trial and error, Ahmed was able to ferment the microbe to produce his target products.
Woo!
And not only that, he has also identified the favorite media, or food, of his microbes, that make them happy and produce high product titer. As what his supervisor, Professor Ward, always remind him, to make the microorganisms happy, is to know what they like the most, and this includes their food. Now, his next mission for his FYP is to recover his product successfully. Apparently, fermentation is not yet the final destination. Here is the untold conversation between the microbes on their very last day of fermentation.
It's a wrap. We survived the fermentation. Well done everyone for your hard work.
So now, what next?
Well, the product that we have produced have to be recovered. So, where are we going?
Depending whether your product is intracellular or extracellular. After the fermentation ends, Ahmed starts the downstream processing by separating the cells from the residual media. Initially, he transfers the culture broth to suitable bottles for conditioning prior to the separation. Broth conditioning is needed for stabilizing the broth in terms of its pH and temperature. Ahmed decides to choose centrifugation as the method to separate the dead cells from the media since the method is suitable for his fermentation broth. Well, actually, there are a few other methods of separation such as filtration, sedimentation, and flotation. To recover an intracellular product, cell disruption is needed. Oftentimes, the process can be challenging.
Humans, the product is inside our cells. You need to break our cell structure by any means.
But make sure the product is safe. So choose the suitable disruption method. There are various disruption methods available. Whichever the method chosen, the ultimate aim is to break the cell wall and to get the product in the cells. Ahmed has to update his supervisor about his progress at the lab from time to time. Here's the advice from Professor Ward. Understanding the flow and rationale of every stage of downstream processing is absolutely the key to success. During another progress meeting between Ahmed and Professor Ward, here is what Ahmed has learned further.
Ahmed, the lysate that you got is not yet 100% of your product. Besides the main product, there are also byproducts that need to be removed. After the disruption and separation, proceed with purification. Make sure you choose a method that is suitable with your target product.
Meanwhile, for Team Extracellular Product, their journey after the primary solid-liquid separation seems to be much simpler. After the primary solid-liquid separation, it is the liquid portion that has to be kept, and not the pellet. Therefore, no cell disruption is needed.
Wow.
This has simplified the process a little bit.
The only difference in main downstream processing steps is the need for cell disruption for recovering intracellular products.
After days of experiments, finally Ahmed has successfully recovered his fermentation products.
Woo!
Oh, what a journey! Well, nothing in the lab is so easy, but passion and perseverance win. Now he realizes that downstream processing is as complex and important as the fermentation process. Because failure to carry out either one will result in no product. In fact, bioprocess is equally made of both upstream and downstream processing. Is there really an end point in research in the lab? Good news or bad news is that nothing in the lab will finish too soon. Till then, see you next time.
This biotechnology comic is brought to you by biotechnologists at UniMars. Please help us to share this comic. Because biotechnology is too awesome not to be shared.